Hello, this is Mr. Marshall for Trigonometry College Year 9 Maths. We're looking at trigonometry. In this unit of trigonometry, you'll be copying down the learning intentions and success criteria into your exercise book. As we go through the slides, you will need to pause to take some notes in your exercise book and then answer the questions found in each lesson in your exercise books. Questions can be found in your Jack Plus textbooks along with the answers to those questions. So today is week 7 and lesson 4, which is applying trigonometric ratios number 2. We're looking at slightly more difficult questions. So today we are continuing finding the missing side lengths using the correct trigonometric ratios. And I am successful when I can calculate the missing side length of a right-angled triangle using trigonometric ratios. So just quickly with the ratios, we start off with our triangle. We always draw it ourselves and we label the sides that we need based on our reference angle down here in the corner. I've put it. So if it's next to the reference angle and the right angle, it's adjacent. If it's across from the reference angle, it's opposite. And as we remember, hypotenuse is the longest side and it's across from the right angle. Next, we work out our trigonometric ratios. This is done with SOH. SO is sine, is opposite over hypotenuse. Ka is cos, is adjacent over hypotenuse. And TOA, tan, is opposite over adjacent. Next, we substitute in all the values. So we'll have two numbers and an angle, or we'll have some pronumerals and an angle, and we'll need to work out what to substitute in. Next step, which is new for these questions, is what's called cross multiplying. We will look at that when we get up to it in the next slide, but that's so that we can get the equation with the unknown by itself. And finally, solve for the missing side. So here's our worked example. Find the length of the side marked M in the triangle and give your answer to 2 decimal places. So we've got the letter M down here. We have our angle of 22 degrees and 17.4. Now with a lot of these pictures, they won't be drawn to scale. So this angle is not 22 degrees. So you won't be able to just measure it with a ruler. You will have to go through these steps. So on the left hand side, I'm going to put my thinking and my steps. And on my right hand side, this is what I'd be showing my teacher as my working. So step 1 was to redraw the triangle and write the sides in. So there's the adjacent, there's the hypotenuse. That's a little different to our drawing from before. We remember hypotenuse is opposite the right angle and adjacent is next to the reference angle down here. So these sides are used with ka from SOH because we've got the adjacent and the hypotenuse. So we write down our rule. Cos of theta equals adjacent over hypotenuse. We then substitute in. So theta was 22 degrees, that's our angle. Adjacent is 17.4, so we put it in the numerator. And M is our hypotenuse, which is down here in the denominator. Now we need to get this so that it is solved for M. So we have M equals something. So the first step for this is we multiply both sides by M. This moves this M here up here. So here's our M. So we've got M times cos 22 equals 17.4. Now we want to get this M by itself. The opposite of a times is a divide. So we divide by cos 22 degrees, put that underneath. And now we've got M equals, and here's our expression for what M equals. Now we can type that into our calculators. 17.4 divided by cos 22 degrees, or for some calculators you can actually write it in this fraction format. and we work out that it's 18.766, and then we round it down to 2 decimal places, so we get 18.77, and we need to remember that because this was in centimetres, we've remembered the units in centimetres down here. Here's a slightly worded example. Benjamin set out on a bushwalk expedition. Using a compass, he set off on a course of north 70 degrees east, or 70 degrees true, and travelled a distance of 5 kilometres from his base camp. How far east did he travel, and how far north did he travel? Now, with this question, we've already been given a drawing, which is excellent. Sometimes they don't have that, and you've got to work it out yourself. Now, this drawing we know is not to scale because this is not 70 degrees. So again, we can't just measure it. We have to go through our trigonometric ratios to work this out. So first off, we're going to look at question A. How far east did he travel, which is the distance along here. So first step, as always, let's label the sides. So we redraw the picture in our books, we label all the sides as hypotenuse, adjacent and opposite, and we leave all the values in there. Now, as I said, we're wanting this one here, the opposite side. So we use our rule, SO, for sine is opposite over hypotenuse, so sine of the angle is opposite over hypotenuse because we want this side here and we have this side. We then put it into our ratio, so 70 degrees, x over 5. We rearrange this now because the x is here. We just have to multiply that 5 to get it up at the side. And then we can rewrite it as x equals 5 sine 70 degrees. And we can type that in our calculators again. We get 4.698. And when we round that off, we get 4.70. Now we can't just write 4.7 because it's asked for 2 decimal places. We need to have the 2 decimal places there. And again, we have to put in our units, kilometres. There's our units for kilometres. So he walked 4.7 kilometres along that edge. So for part B, we go through the same steps. We draw the diagram. Now, we already had this diagram. As you'd be doing this in your book, you'd only have to draw it once. You wouldn't have to draw it for both parts. Next, we want adjacent hypotenuse, so we're using the CA, which is cos of the angle equals adjacent over hypotenuse. Adjacent hypotenuse. Substitute in the values. Cos of 70 degrees equals y over 5. Solve it. So again, we just get that 5, move it up, and we get y equals 5 cos 70 degrees. Type it in our calculator, 1.710, and we can round that to just 1.71. And again, we have to remember to have those units. So our exercises for practice level students, you will be doing just these exercises. Make sure you do your drawings in your book. Consolidated level students, those questions, and again, copy the diagrams. And master level students, these ones here, drawing up your diagrams. Okay, our reflection for this lesson. How are sine and cosine related to each other? And what are the similarities between these two functions?